Good morning. It's August 18th, and this is your daily brief in science. Here's everything you need to know. An active underwater volcano off Vancouver Island has been found to serve as a critical nursery for over 1 million giant eggs of the Pacific white skate, challenging previous assumptions that the site was extinct. This volcanic area provides a rare view into how deep-sea species adapt to extreme conditions, functioning as a natural laboratory for studying evolution and ecosystem resilience. The skate eggs, nearly 20 inches long with leathery shells, contain nutrients that improve embryo survival in the harsh environment, with their large size indicating significant parental investment. The volcanic environment creates a unique nursery resembling a coral garden, which is essential for the early development of skates and other deep-sea species. The Pacific white skate can grow up to 6.5 feet and inhabits depths from 2,600 to 9,500 feet, demonstrating notable adaptations to the deep-sea environment. The discovery highlights the ecological importance of volcanic habitats in supporting biodiversity and emphasizes the need to conserve these fragile ecosystems amid environmental threats. The geothermal warmth from the volcano accelerates the skate egg's 4-year gestation period, providing a natural incubator that supports early development and enhances hatchling survival. Follow-up research in 2023 confirmed a skate laying an egg at the site, indicating its ongoing reproductive significance. The volcano, previously thought dormant since 2019, was found venting mineral-rich hot water that sustains deep-sea corals, sponges, and a large deposit of skate eggs on its summit. This finding underscores the importance of protecting deep-sea ecosystems from threats like climate change and mining, as they may contain vital clues to life's resilience on Earth and possibly beyond. Recent research indicates that certain infectious diseases emit specific odors, potentially transforming medical diagnosis through non-invasive methods. For example, a sweet smell in stool may signal infections such as cholera or Clostridioides difficile, while tuberculosis can produce foul odors on breath and skin resembling stale beer and wet cardboard with brine. Industries like food, beverage, and fragrance are already utilizing odor analysis, demonstrating the technology's current applications. Scientists are exploring how this approach can be expanded into healthcare diagnostics as understanding advances. Dogs have shown high accuracy, with some studies reporting up to 99% success in detecting prostate cancer via urine samples. These trained animals can identify a range of conditions, including cancers and neurological diseases like Parkinson's, due to their highly sensitive sense of smell. This sense is estimated to be up to 100,000 times more acute than that of humans. However, training dogs for medical detection is lengthy, and not all dogs are suitable, prompting the development of laboratory techniques that mimic canine olfactory capabilities. One such method involves using gas chromatography mass spectrometry, or GCMS, to analyze skin sebum for diseases like Parkinson's by separating and quantifying disease-specific compounds. Researchers are also working on analyzing disease-related odors through various techniques, aiming to replicate olfactory detection in laboratory settings. Recognizing unusual odors in bodily functions and consulting healthcare professionals can lead to earlier diagnosis and improved health outcomes. Researchers at EPFL have introduced a new numerical method to simulate topological quantum systems, focusing on quantum spin liquids. This method uses a time-dependent variational Monte Carlo scheme, allowing for scalable and flexible simulations that do not require approximating system size, shape, or duration. The approach addresses previous limitations by more accurately capturing complex correlations and managing systems with high entanglement. It enables precise predictions of properties such as topological entanglement entropy, which helps distinguish genuinely topologically ordered states from disordered ones. The team was motivated by experimental observations that earlier models failed to replicate accurately, aiming to deepen understanding of these quantum states. They utilized a parameterization technique that encodes key features like correlations within the wave function, overcoming traditional methods' difficulties with entanglement. The researchers plan to adapt their method to explore other quantum systems and investigate the states generated through their simulations. This approach can be adopted by other research teams to simulate quantum spin liquids, explore their dynamics, and extend to other quantum devices and protocols. Looking ahead, they aim to simulate more complex quantum devices and better understand the characteristics of the states produced. This advancement represents a significant step forward in the simulation of complex quantum states and paves the way for future research in quantum device development. Recent research highlights a significant gap in understanding female-specific biological factors in mental health, largely because women have historically been underrepresented in medical studies. This underrepresentation has contributed to less effective and potentially unsafe treatments for women. To address this, animal models, especially rodent studies, are increasingly used to explore sex-specific brain mechanisms, aiming to develop more personalized therapies. Some mental health disorders, once considered more common in men, such as alcohol use disorder, are now rising among women, underscoring the need for sex-specific research. Major organizations like the U.S. National Institutes of Health and Australia's National Health and Medical Research Council are implementing policies to include biological sex as a key factor in research. Recent animal studies, including mouse models, have demonstrated sex-specific neural mechanisms. For example, reducing ghrelin receptor activity decreases binge drinking in females, but not in males. The scientific community is working toward a better understanding of these differences to create targeted, effective treatments for women. Including both sexes in research can lead to more personalized healthcare and help close the gender gap in mental health understanding and treatment. Women are disproportionately affected by the global mental health crisis, experiencing higher rates of anxiety, depression, PTSD, and eating disorders compared to men. A new study from the University of Birmingham examines how probiotics can influence the gut microbiome of preterm infants. The research focused on 34 infants born before 33 weeks gestation, some of whom received probiotics containing Bifidobacterium bifidum and Lactobacillus acidophilus, while others received short courses of antibiotics. During the first 3 weeks, infants who received probiotics showed a gut microbiome dominated by beneficial bacteria like Bifidobacterium. These infants also had fewer early-life pathogens such as Klebsiella, Escherichia, Enterococcus, and Staphylococcus. Conversely, infants who did not receive probiotics harbored more multi-drug-resistant strains, including E. coli ST1193 and K. pneumoniae ST432, and carried higher plasmid burdens linked to horizontal gene transfer. The findings support the increasing use of probiotics in UK neonatal intensive care units, guided by WHO recommendations, to help prevent infections and promote healthier microbiome development. While further research is needed to optimize probiotic strains, dosing, and duration, the results indicate that probiotics are important for antimicrobial stewardship and limiting resistance. The study also demonstrated that resistance-carrying plasmids can transfer between bacteria after antibiotic exposure, confirming the potential for horizontal gene transfer. Functional pathway analyses showed that probiotic use was associated with decreased antibiotic resistance genes, especially to last-resort antibiotics like colistin, by the second week. Additionally, probiotic treatment was linked to lower levels of drug-resistant pathogens such as Enterococcus, which are associated with infection risks and longer hospital stays. Rapid colonization by probiotic Bifidobacterium was confirmed through sequencing, aiding microbiome maturation and reducing resistant pathogens. Short antibiotic courses alone did not significantly increase diversity, but were linked to early colonization by Klebsiella or Enterococcus and increased horizontal gene transfer. Overall, the study highlights that probiotics can play a key role in reducing antimicrobial resistance and improving gut health in preterm infants, though further research is necessary to refine their use. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.